All right, so anytime that you are looking at a two-way frequency table, you want to find totals in both directions. So totals of highest honors is going to be 98 here, and our totals of academic excellence are going to be 127. And then I'm going to have my total 10th graders as 80, my total 11th graders as 75, and my total 12th graders as 70. Then you add 80, 75, and 70, and hopefully we also get 225 when we add 127 and 98. And we do. All right, so in order to start looking at these questions here, we're going to we need to find these individual probabilities. So the probability that we have a 10th grader is 80 out of 225. So that's the probability of a 10th grader. Then we have the probability of a 12th grader is 40. Nope, that's 70 out of 225. Then the probability of highest honors is 98 out of 225. Then the probability of academic excellence is 127 over 225. So now we're supposed to compare these two probabilities. So this is the probability that they are in 10th grade given they have the highest honors. So there are only 98 people of whom it could be the highest honors. So the 10th graders of that are 36. So that's going to be 36 out of 98. And that's going to give us about 0.367. Then here, the probability that they're in probability that they got highest honors given that they are 10th graders is, well, their total number of 10th graders is 80, and the number of them that got highest honors is 36. So that's going to be 36 out of 80, and that's going to be 0.45. So here, our symbol goes that way. So what this means, it is more likely that they will have highest honors given that they're in 10th grade than that they will be a 10th grader given that they have highest honors. So if you go to the group of 10th graders, and so it's basically saying, like, given that they're a 10th grader, it's more likely that they will have highest honors than that they will have achieved being a 10th grader given that they have highest honors. So that's basically it there. All right. So looking here, and one of, like, if you look at this and you see highest honors in 10th graders, you see, wow, there's the most of them. But also, look, they surveyed the most of them. So you have to think about that. All right, so number 4 here is it wants to know whether they are independent. So here, this would be the probability of 10 given HH would be the same as the probability of 10. Well, we know that the probability of 10 given HH is, where do I have this written down? Right there, is 0.367. And the probability of just being a 10th grader is 70 over 225. So, is that a 70? Being a 10th grader, an 80, excuse me, being a 10th grader is 80 over 225. So 80 over 225 is equal to 0.357. So that's basically saying that you've got a 36.7% chance and then a 35.5% chance here. Those are about equal. We know they're not exactly equal, but we would say that they're pretty independent as variables there. So it's saying that being a 10th grader does not having highest honors does not impact your probability of being a 10th grader. And if you look at that the other way, it would be the probability of HH given 10 would be the same as the probability of HH. Well, the probability of HH given 10 was 0.45, and the probability of just highest honors was 98 over 225. And when you divide 98 by 225, you get 0.44. So that's going to be 45, 44. Again, they're roughly the same. So looking over at number 5 here, we're going to compare the probability that they are in 12th grade given they are academic achievement. So the academic achievement there is 127, 12th grade, so that's 40 over 127. And that's going to be approximately 0.315. Then here, the probability that you're in 12th grader given academic achievement, so that's 40 out of 70, so that's about 0.57, and those are not roughly equal. That's about 32% and 57%. So the word looking forward, it's likely that those are going to be dependent, but right now we're just, because again, we can't super compare those because we're comparing the conditionals. But right now, what we do know is it's significantly more likely this way. So we know that it is significantly more likely that you are have academic excellence given that you're a 12th grader than that you are a 12th grader given that you have academic excellence. So, all right. So looking here, we're going to compare whether these are independent or dependent. And I might have told you a falsity up here, which I did, because again, when you compare the conditionals, you can't make the independent dependent. I got way too excited there. So here we're going to have the probability of 12 given AE is going to be equal to the probability of 12. So the probability of 12 given AE, that was 0.315, is equal to the probability that they are a 12th grader. Well, that was 70 over 225. And 70 over 225 is equal to 0.311. So that's 31.5% and 31%. So those are almost equal. So again, we would say that these are independent. So being a 12th grader and is not impacted by one's academic achievement. And then here we can check the other way. So that would be PAE given 12 would be equal to the probability of academic achievement. So there, that's going to give us 0.57. And then academic excellence, was 127 over 225. And 127 over 225 is 0.564. So again, we know they're not perfectly independent, but it's saying that the role of 12th grade and academic achievement are independent of one another. One doesn't seem to have an impact on the other. All right, so I hope again that that was helpful. If you don't need to look at the next one, don't look at the next one. So here we're looking at situations here. So total number of people that said pizza is 50. Total number of people that said cold cut sub is 49. Total number of people that said chicken tenders, 51. Salad, 50. Total number of people that said juice, 99. Milk, 101. All right, so we're not going to find all of them because we don't need all of them. So here they want us to compare these and then determine if they are independent. So here we go. And actually, I'm not going to talk through all of these. I'll show all of the different probabilities, but I'm not going to talk through this whole thing. So if you really need to look at one of these specifically, hopefully I'll have the probabilities listed out and that'll help you think about that.